Finding the position, $n, of a given term. Now, if you look at our previous lessons, we spent a lot of time learning how to find the value of a specific term, which we call a sub n, provided that we already knew its position, or n, it was a straightforward process of plugging numbers into a formula to find the result. However, in many mathematical problems, and even in many real-world scenarios, we often face the exact opposite challenge. We might know the final value of a term, but we have no idea where it sits in the sequence. We don't know its position. In this subsection, we are going to learn how to flip that logic. We will explore the steps needed to determine the value of n, which is the position, as long as we are provided with the first term, which we call the common difference, which we call d, and the value of the nth term, which we call a sub n. By the end of this session, you'll be able to work backwards through the sequence with confidence. Welcome, everyone. Let's begin our new lesson on finding the position of a given term. Understanding the logic. Now that we understand the problem we are trying to solve, let's look at the logic behind finding the position. To find the position, which we call n, we start with the general formula for the nth term of an arithmetic progression. You might recognize this from our previous lessons. A sub n equals a plus the quantity n minus 1 multiplied by d. But as I mentioned in the first slide, we aren't looking for the value of the term this time. We are looking for the position. So, our goal is to isolate, and we can do this by rearranging the formula using some basic algebra. First, we start by subtracting the first term, from both sides of the equation. This leaves us with a sub n minus a equals the quantity n minus 1 multiplied by d. Next, to get closer to n, we need to get rid of that common difference, d. We do this by dividing both sides of the equation. Now, we have a fraction where a sub n minus a is the numerator and d is the denominator, and this whole thing is equal to n minus 1. Finally, to solve for n completely, we need to undo that subtraction of 1. So, we add 1 to both sides. This gives us our new, rearranged formula. N equals the quantity a sub n minus a all divided by d plus 1. By using this rearranged version, we don't have to do all those algebraic steps every single time. As you will see in the next slide, we can use this direct formula to jump straight to the answer. Step-by-step procedure to find $n. Now that we have seen the algebraic logic behind rearranging the formula in the previous slide, let's break this down into a clear, step-by-step procedure that you can apply to any problem. To make things easier, I've broken the process into 5 manageable steps. Step 1, your first task is to act like a detective. Read the problem carefully and identify and list your known values. You need to find the first term, which we call the common difference, which we call d, and the specific value of the term you are looking for, which we call a sub n. Step 2, once you have your values, substitute them into the general formula. You'll take those numbers and plug them into the formula. A sub n equals a plus the quantity n minus 1 multiplied by d. Step 3, now we begin the algebraic simplification. The first move is to subtract the first term, from your term value, a sub n. Step 4, next, take that result and divide it by the common difference. This will leave you with just n minus 1 on one side of the equation. Step 5, finally, to isolate n and find the actual position, you must add 1 to your final result. If you follow these steps precisely, you'll avoid the common pitfalls we'll discuss later. To see this exact process in action, let's move on to the next slide, where we will apply these steps to a real-world savings scenario. Real-world example. Now that we have understood the logic and the algebraic steps behind rearranging the formula, let's put everything we've learned into practice with a real-world example. Imagine a student is starting a new savings plan. In the very first month, they set aside $50. To build their savings, they decide to increase their monthly savings amount by $20 every single month. The student's goal is to figure out exactly which month their monthly savings will hit the target of $210. To solve this, we will follow the 5-step procedure we just discussed. Step 1. We need to identify and list our known values from the scenario. Our first term, which is the savings in month 1, is A equals 50. Our common difference, representing the monthly increase, is D equals 20. The value of the nth term, which is our target savings, is a sub N equals 210. Our goal is to find the position, which is N. Step 2, we substitute these values into our general formula. This gives us 210 equals 50, plus the quantity n minus 1 multiplied by 20. Step 3, now, we follow our algebraic steps by subtracting the first term from both sides. 210 minus 50 leaves us with 160. So, 160 equals the quantity n minus 1 multiplied by 20. Step 4, next, we divide both sides by our common difference, which is 20. 160 divided by 20 equals 8. This leaves us with 8 equals n minus 1. Step 5, finally, we isolate n by adding 1 to both sides. 8 plus 1 gives us 9. Therefore, n equals 9. To conclude our calculation, we can see that the student's monthly savings will reach exactly $210 in the 9th month. As we move to the next slide, I want you to pay close attention, because while this calculation worked out perfectly, there are a few common pitfalls that could lead you to the wrong answer. Common mistakes to avoid. First, let's talk about the most frequent mistake, forgetting to add 1. When you are working through the algebra, you will often reach the step where you have calculated the value for n minus 1. It is incredibly tempting to stop right there once you have finished the division. However, please remember that the formula we derived earlier is for the term n minus 1, so you must perform that final step of adding 1 to find the actual position, n. Second, keep a close eye on your signs, especially when dealing with negative differences. If you are working with a decreasing arithmetic progression, your common difference, d, will be a negative number. You must be very careful when dividing. For instance, if your subtraction results in a negative numerator, remember that dividing a negative number by a negative d should result in a positive value for n minus 1. A simple sign error here will lead you to an incorrect position. Finally, pay attention to the type of number you get as a result. In a standard arithmetic progression, the position n must always be a positive integer, like 1, 2, or 3. If you follow all the steps correctly but your calculation results in a fraction or a decimal, this is a major red flag. It means that the value you were given for the nth term is not actually a part of that specific sequence. Now, before we wrap up today's lesson, I want to pause and discuss some common pitfalls. Even if you understand the logic we discussed in the previous slides, it is very easy to make small errors during the calculation process. Keep these points in mind as you practice, and you'll find much more success. Now, let's move to our final slide to summarize everything we have learned today. Key takeaways. First, remember that the position, which we call n, isn't just a number. It represents the rank or the specific order of a term within the sequence. It tells you exactly where that term sits in the line. Second, if you ever forget the algebraic steps we practiced in slide 2, you can use this direct formula. N equals the quantity a sub n minus a all divided by d plus 1. This is a great shortcut to have in your toolkit. Third, and this is a very important check for your work, the value of n must always be a positive integer. Since you can't have a 2.5th position in a sequence, if you calculate a decimal, you'll know immediately that something went wrong or that the value provided isn't actually part of the sequence. Finally, don't let the terminology intimidate you. At its heart, finding n is simply a matter of solving a linear equation where n is your unknown variable. If you are comfortable with basic algebra, you are already halfway there. All right, we have reached the end of our lesson. Let's quickly recap the key takeaways to ensure you have a solid grasp of how to find the position of a term. I hope this breakdown helps you approach these problems with confidence. Great job today.